Hey, welcome back. This is our last video reviewing our factoring tools from the first quarter. In this video, we're going to cover grouping, which is how we factor cubic polynomials. So far, we've covered how to factor things with two terms, with difference of squares, difference in the sum of cubes. And then we also covered how to factor quadratics, which are things with three terms, with an x squared term. And then now we're going to cover how to factor cubics, which would be with grouping. Okay. To do this, we want to split these into separate groups to start. Whenever we see a cubic that has all of its terms like this, we know we're going to use grouping. That's the only method we've used. So if I split this into groups, I have x cubed, positive 4x squared, that'll be my one group. Then in a different group over here, I'm going to do negative 9x and negative 36. Now our goal with this is to pull out a common factor from each of these. And I'm leaving spaces here blank. I'm going to pull out a common factor from both of these groups. And then whatever we get left over after we pull out a common factor should be the same thing after we pulled out a factor. So that's our goal. All right, if I look at these first two, x cubed and 4x squared. I like to first look at the numbers. I'm going to pretend there's a 1 there. A 1 and 4. Well, there's really no common factor between 1 and 4 other than just 1. 1 is something that we could divide into both of them, but it's not very exciting. I'll put it there just in case. Then I'm looking at the x's. I notice in this first one we have 3 x's being multiplied together. That's the same as saying x times x times x. In the second one we have 2 x's being multiplied together. So I see they share in common at least 2 x's. So I'm going to pull out a factor of x squared. That's saying they have at least 2 x's in each of them, so I could divide out x squared from both of them. Now I'm going to do that work in black. So once we identified our common factor, we write it down there, over here, and we have to divide it out of our current terms, which is what we do when we factor things. We're sort of like dividing them out into multiples. All right, the first one, x to the third divided by x squared. It's like saying we have 3 x's multiplying and we're dividing out 2 of them. That leaves me with just x to the 1, or just x left over. Leave the 1 there. And then over here, 4x squared divided by x squared. Well, 4 is going to be there. We have to figure out how many x's are left over. X squared divided by x squared. So we have 2 x's and we're dividing out 2 x's. That means we have no x's left over. We have x to the 0, which is equal to 1. Another way to think of it is whenever we divide something by itself, we just get the number 1. So however you think about it, we had x squared in common. We divided it out from both of our terms, and we're left with x plus 4. Hopefully we can do the same thing to this group on the right, and we should end up with, like we predicted, an x plus 4 in the parentheses after we pull out our common term. In this one, I noticed that, well, there's a negative in both of these, and we know we want, in our final factor, we want both our terms to be positive. We want a positive x and a positive 4. So I know at least I'm going to want to divide out a negative. I need something then that can, the biggest thing I can, that can divide into both of these. Well, the biggest thing that can divide into 9 is 9. So let's see if 9 also divides into 36. And I have a calculator here in front of me. 36 divided by 9 is 4. So we want to divide out a negative 9 from both of these. That'll take care of this first one. A negative divided by a negative is going to be a positive. That's good because that's what we wanted. We had a positive x in the other one. It's going to be a positive, and then a 9 divided by 9 is just 1. So a positive 1x or just a positive x. Then we have a negative 36 divided by a negative 9. Negative divided by negative is a positive. 36 divided by 9 is 4. Great. So first we pick our common factors, we pulled them out, we ended up with this same group, and I'm going to kind of like go around it here in green. we end up with this common group now, both of them factored into x plus 4. So just like we did before, we're going to take this common group and pull it out front. X plus 4 is a common factor. We're pulling it out front. To get rid of it, I'm going to divide it out. When we divide something by itself, it just goes to 1, goes to 1. And then all that's left over inside, let's see, for this first bit, we have an x squared left over after we divided out the x plus 4. For the second half, we had a negative 9 left over. So both of these factors divided out. Now we have a little bit better. We have our original cubic. Remember, it was originally 4 terms. Here I'm underlining in blue. Our original cubic we've split into 2 factors. One factor is x plus 4. The other is x squared minus 9. Now the first term's factored all the way out. We can get it 0 already. X plus 4 equals 0. Subtract 4, x equals minus 4. So we got 1, 0 from that first term already. The second term isn't broken down all the way yet. I see there's still an x squared, which means we might be able to factor it more. Well, if I look back at my patterns, we only have these tools. It has 2 terms. You know, it looks an awful lot like it's got a squared term and 9. 9's a perfect square. And there's a subtract. So it looks an awful lot like a difference of squares. Difference of squares. And that formula is a squared minus b squared equals a plus b times a minus b. And then matching these up, that's my a squared, there's my b squared. My a is going to be x in this case, because x times x gives us x squared. And my b will be 3, because 3 times 3 gives us 9. And again, review back to our difference of squares method up here, if that feels rusty. But I noticed it's difference of squares, and I can split it up now into 2 factors. And get our 2 more solutions. Great. So we've taken our original cubic. We actually factored it all the way down into its 3 linear terms, 1, 2, and 3, to give us our 3 solutions. So that's it for a review of how we do these methods on the backside. For practice, questions 4, 5, and 8 all do a good job, are all examples of how you could use grouping to factor a polynomial and get some solutions. Notice in this one, we were able to use difference of squares at this step right here. Sometimes we won't be able to do that. Sometimes we may end up with something like, well, I don't know. If instead we had x plus 4 times x squared plus 9, this term here doesn't look like a difference of squares. Not difference of squares. We could try and treat it as a general quadratic, like x squared plus 0x plus 9, and maybe try and use our quadratic formula on it. 0 plus or minus the square root of 0 minus 4 times 1 times 9 all over 2. That would leave us with the square root of 36, negative 36 all over 2. So if this is something we run into, if you get a positive like an x squared plus something, right now we're not going to be able to get any real solutions to that because we can't have a negative under a square root. If you tried this in a calculator, it would give you not a real solution. Later in the year, we'll be able to find imaginary solutions, but for right now, we don't get any real solutions from something like that. So if you run into a situation like this on the backside where you end up with something that you can't factor as a difference of squares, and you could try it as a quadratic, but you're not going to get any real solutions. No real solutions. Just be aware that you may only have one solution to for your cubic polynomial. All right. Good luck with this. Remember to take these notes, try out these practice problems, and then in class you'll have a chance, well, bring them back to class, and then you'll have an opportunity to make up some related assignments that you missed.